Okay, can we start new topic? Today we're going to look at chapter number 7, hypothesis testing for single population. And next week, probably we will look into chapter 8, hypothesis testing for two population. Right. So learning objective, at the end of this chapter, you should be able to describe the hypothesis testing, define what are type of error in hypothesis testing, describe critical region and p-value in hypothesis testing, describe the procedure for hypothesis testing, perform hypothesis testing, use relationship between confidence interval and hypothesis, calculate the p-value and compute the probability type 1 error and type 2 error, right? So now let's start with the first slide. So this slide start with when we don't know the value of population parameter, then we can estimate the value, right, by using estimation method. So I think last class in chapter number 6, we already learned how to estimate the value for parameter, value of from sampling distribution, right? And we can estimate the value of parameter, population parameter. So when we already estimate the value, then we need to test whether the value is that we already calculate is correct or incorrect, right? So then we need to do hypothesis testing lah, to test whether the value that we already calculate correct or not, right? So in hypothesis testing, so what is claim or hypothesis testing, right? A claim can be either, this is an example of claim lah. A product can make a person lose weight, become fairer, and make you smarter. This is a claim. A lecturer might wish to see whether new teaching method is better than traditional one. Right, so we want to compare between two procedure, new teaching method and old teaching method. So we want to know whether is there any effective or defective. Right, so how to determine whether this claim or hypothesis are true? So then we need to use test of significance or hypothesis testing, right? So in hypothesis testing, basically we would like to test the claim made for certain subject lah. Right, so now slide number 3. So hypothesis is a statement about the population parameter developed for the purpose of testing. Let's say we want to test whether the mean weight of student in a class is less than 73 kilos, right? So we claim that mean weight of all students in this class less than 73 kilos. So we want to test whether the claim is true or not. We need to collect the data and prove with the statistical test. Right, so now hypothesis testing is actually a procedure based on the sample evidence and the probability theory to determine whether the hypothesis is reasonable or not reasonable. Right, so we're going to test the claim whether it is true or not true. So the objective of hypothesis testing is to check the validity of a statement about the population parameter. For example, as I said before, I claim that the mean weight of all students in this class is less than 73. So I need to prove whether the claim is true or not by using the hypothesis testing. Right. So since this the statement made is about population parameter, to do the test, we will take the random sample, right, from that population and calculate the sample statistic, which is X bar, right, from the sample. So we're going to calculate the X bar and we need to determine the standard deviation, sample standard deviation of population standard deviation, yes, population variance, right? So from the sample, the information from the sample, we will make a decision whether to reject or not to reject the statement made, right? So this is all what hypothesis testing all about lah. So now let's look at this slide, definition term. So hypothesis, as I said before, is a statement about the value of the population parameter. So let's say it can be either mean weight less than 73 kilos. So this is the claim, right? So to prove whether this claim is true or not, then we need to do the hypothesis testing, which is the method tell us whether to accept the claim or to reject the claim, right? So in hypothesis, there are two type of hypothesis, right? One is null hypothesis, another one is alternative hypothesis. So null hypothesis note as H naught, alternative hypothesis is H1 or HA. Some will put HA lah, right? So we will use H1 to indicate alternative hypothesis. So the claim is on alternative hypothesis. The null hypothesis is opposite of the claim, meaning the claim is not true. Means that when our claim is the mean weight of all students in this class less than 73, so the opposite of this claim will be the mean weight is equal to 73 or more than 73, right? So alternative hypothesis, mean is less than 73, right? So let's look at this one. Null hypothesis is a claim or statement about the population parameter that assumed to be true until it declared false, right? Statistical hypothesis state that there are no difference between the parameter and specific value, or there is no difference between two parameters, right? This is an example of null hypothesis, mu equal to mu naught. Mu naught is some value lah, right? Okay. So alternative hypothesis is the opposite of null hypothesis. This hypothesis will be accepted if null hypothesis is rejected, right? This is also known as research hypothesis, right? So there are two types of hypotheses, which is one-tail test and two-tail test, right? So this is example of two-tail test, whether we are testing not inequality, which is mu is not equal to some value. So let's say mu, we say that mean weight is not equal to 73. So they're going to be a two-tail test where we are looking into two-sided rejection area, right? So it's going to be two-tail test. Maybe this one should be negative Z alpha divided by 2, and this is Z alpha divided by 2, right? Where this is a rejection area and this is acceptance area. So if the value of calculated statistical test lies inside the acceptance region, then we will accept null hypothesis, right? So this is an example of one-tail test, whether we are looking into more than or less than, right? If the test is more than, let's say, mean weight more than 73, we are looking into one-tail test to the right. To the right. So this is the rejection area. So please pay more attention on this one. This is a fundamental. If you fail to understand this one, then the following topic also cannot be understood. Right. Another type of one-tail test we have to the left, which is mu less than 73, mu less than mu naught. So this one we are measuring the area to the left, which is less than. So this is the area of rejection region. And this is acceptance region. So when the statistical value, right, which is Z value or T value, lies inside the acceptance region, then we will accept null hypothesis. If the statistical value lies inside rejection region, then we will reject null hypothesis and accept alternative hypothesis. Right. So another term that we need to understand is significant level. Right. Significant level is the value that we made as a threshold. Right. How many rejection area that we want to accept. Right. So this is the rejection area. So we want to know how large the rejection area, whether 5% rejection area or 10% or 20%, right? So significant level is a probability of rejecting null hypothesis if it is true, right? The level of confidence that correspondent to alpha is 1 minus alpha. Means that if you want your test to be 90% correct, right? So the balance of 90% is 10%, right? So alpha will be 10%. So the 10% is we reserve for any miscalculation. So we want to minimize our miscalculation. So normally we will take 5% or 1% lah. Alpha equal to 1% or 5%. Right. So the confidence level of 90% corresponding to alpha of 10%. Right. So another term in hypothesis that we need to remember, understand is test statistics. So it's a single number calculated from sample data. So we already learned in chapter number 6, right? The Z value, the T value, right? So we will use back the statistical techniques in this chapter. So the test statistic is entire set of value of that test statistic may assume is divided into two regions, right? Either to the left or to the right, right? So in test statistic, we also need to calculate the critical region. So what is the critical region? As I said before, we are looking into one tail or two tail of hypothesis testing, right? If we are looking into one tail, let's say the null alternative hypothesis, the null hypothesis mu equal to 73, right? Alternative hypothesis mu less than 73. So apa maksud ni? This is what I claim that the mean weight of all students in this class is less than 73 kilos. So this is my claim, should be in alternative hypothesis, right? The null hypothesis is the opposite of alternative hypothesis, which is mu is equal to or more than 73. It can be more equal to or another one more than, right? So since the alternative hypothesis is less than, so the area that we are looking at is to the left. So this is Z alpha, right? So Z alpha is a threshold, where is a line where divide between rejection region and acceptance region. So this is acceptance region, rejection region. And this is acceptance region. So Z alpha is known as critical value. So critical value is the value of test statistic that divide the non-critical rejection region from the rejection region, right? So if the test statistic that we already calculate here, so let's say we are using Z, x bar minus mu divided by sigma over square root of n. So let's say we take, we got 2.15. Right, let's say Z alpha is equal to 1.96, right? So since this one is 1.96, so negative 1.96, this is negative 2.15. So negative 2.15 lies inside the rejection region, right? This is example, nanti kita tengok ada detail, right? So since Z calculated, negative 2.15 lies inside the rejection region, so then we will reject null hypothesis, right? We will reject null hypothesis and we accept alternative hypothesis. And we conclude based on alternative hypothesis, right? Where the mean weight of all students less than 73, right? Any questions so far? No question, right? So now, so this is example of one-tail test, right? Suppose that the average number of kilometer per liter obtained with a carburetor is 20 kilometer liter, right? If you want to show that the average number of kilometer obtained with certain carburetor is more than 20 kilometer, then the hypothesis will be, this is a claim, right? Our claim is more than 20 kilometer per liter. So it should be on alternative hypothesis. And null hypothesis is mu equal to 20. So this is what we call as one-tail test. So to determine whether one-tail test or two-tail test, we just look at the alternative hypothesis. So this is alternative hypothesis, right? So this is null hypothesis. So since there are more than, the area of rejection will be, so this is a normal distribution. So in this subject and topic, we will look into normal distribution and T distribution, right? So T distribution comes from normal distribution, so it will look like normal distribution as well. So the rejection area will be on to the right, right? So this is Z alpha. So this is a rejection region. This is acceptance region. So if the Z calculated less than Z alpha, then null hypothesis is accepted. If Z calculated more than Z alpha, null hypothesis is rejected. Okay, so this is the rule whether to accept or to reject null hypothesis, right? So of course we need to calculate the Z calculator, Z statistics and the critical region, which is this one, to divide between rejection region and accepted region. Okay. Any questions so far? No question? Right. So now let's look at example number 2. We also have one-tail test. So in this case, we want to show that the average number of kilometer per liter obtained with certain carburetor is less than 20 kilometer per liter. So the claim will be on alternative hypothesis. So this is a one-tail test because the alternative hypothesis shows a symbol less than or more than, right? So this one, the area that we are looking into as is at to the left. So this is 0 to the left. So this is Z alpha. This is rejection region. And this is acceptance region, right? So same as previous, if the Z statistics lies inside the acceptance region, null hypothesis is accepted. If Z statistic lies inside the rejection region, null hypothesis is rejected. Boleh faham? So if we reject null hypothesis, we will accept alternative hypothesis and conclude based on alternative hypothesis. Very simple, right? So another example, this is example of two-tail test, right? So in this example, we want to show that the average number of kilometer per liter obtained with certain carburetor is different than 20 kilometer per liter. So means that it's not equal to 20 kilos. It's different, right? So this is the claim. Null alternative hypothesis, mu is not equal to 20. So when we have not inequality, right, this is mean two-tail test. So we are looking both side, right and left. So we're going to have two rejection area. So on the right and left. So this is Z alpha divided by 2, negative Z alpha divided by 2, and Z alpha divided by 2. This is rejection region. This is also a rejection region. And this is acceptor region. Okay. So if Z statistics lies inside acceptor region, then we accept null hypothesis. If Z statistics lies inside rejection region, we reject null hypothesis. Right? Boleh? Right. So this is a common phrase for hypothesis testing. So if you have more than or equal to, less than or equal to, this is one tail test. And this is two tail test. Right? Okay. Step in hypothesis testing. So this is the first step. When we want to conduct or perform a hypothesis testing, the first step is we need to state the null hypothesis and the alternative hypothesis. So this is a hypothesis statement. So null hypothesis is a statement about the population parameter. Alternative is a statement that is accepted if the sample data provide enough evidence the null hypothesis is false. Right? So alternative hypothesis is our claim. So we want to prove the claim. We need to collect the sample data and make sure the sample data leads to the alternative hypothesis. Right. Second step is, this is step number 2. Step number 2, we state the level of significance. So this is step number 2. State level of significance, which is 0.05 or 0.01 or 0.1 or 0.02 or something else. Right. So what does it mean? It means that if we want to get the confidence of the power of the test, let's say we want to have 95% confidence that our statistical test is correct, right? So the balance is 5%. 5% reserved for making type 1 error, right? Making a wrong calculation, right? Later we will look into what is type 1 error and type 2 error, right? Step number 3, we select the statistical test, which is test statistics. So in our topic, we will look into standard normal distribution and T distribution, right? Of course, in standard normal distribution, we will look into when the population is normal distribution, variance is known, right? Variance is known. And another standard normal distribution is variance is unknown. The population variance is unknown, but we have a large sample size, right? This is where we have a look into central limit theorem last chapter, right? When n is more than 30. And for unknown variance, population variance unknown, but the sample size is very small, then we will apply T distribution, right? So this is test of mean, right? So we can divide into two, right? Population variance known, population variance unknown. So when the population variance known, we will use Z distribution where X minus mu divided by sigma over square root of N. So this is a test statistic. When variance is unknown, population variance unknown, we will look into two conditions, whether N is more than or equal to 30 or N less than 30. Right. So when N more than or equal to 30, so we will use standard normal distribution where X bar minus mu divided by S over square root of N. When sample size less than 30, we will use T distribution X bar minus mu S over square root of N. Okay. So this is a choice of statistical test that we will use for testing mean on single population. Okay. Any questions so far? Right. So, yes. So this is step number 3. Step number 1 is state the hypothesis statement, which is null hypothesis and alternative hypothesis. Step number 2, state your significant level, which is alpha, type 1 error, the probability of type 1 error. Step number 3, we will select the test statistic. Right? To select test statistic, we will look into these 3 conditions for testing mean, right? And later we will look into testing the proportion, and variance we will not going to look into in this subject. Right? Step number 4, we will state the decision rule, but to state the decision rule, we need to calculate the critical region. Right? Remember critical region? I already mentioned just now. Let's look at this one, this distribution. The critical region is the value that divides between rejection area and acceptance area. Right? So we will calculate the critical value and determine the critical region. Then we will step number 4. We will state the decision rule. What is our decision rule? If Z statistic or T statistic based on the test statistic, this one, lies inside the rejection area, we reject null hypothesis. If the Z statistic or T statistic lies in acceptance area, we accept null hypothesis. Can you understand? Boleh? You all okay? Macam pernah belajar, macam sama aja, tak ada apa. Okay kan? Pernah belajar sebelum ni? Tak pernah. This is first time. Right. So you understand my explanation, okay? Boleh? So step number 5, we will make a conclusion. Right. So we're going to have 5 steps. Step number 1, state hypothesis statement. Step number 2, significant level. Step number 3, test statistic. Number 4, critical region and decision rule. Step number 5, make a decision and conclusion. Right. So this is a step in example of test statistics. So I think I already explained just now. So if you have 2 tail tests, then alternative hypothesis will be not equal, right? So we're going to have 2 rejection area, and when we have less than mu naught, so it should be on the left. If you have more than mu naught, it should be on the right, right? So this is 1 tail test, 1 tail test. Right. So in hypothesis, to test the claim, we need to select a sample from the population and measure the sample statistical value, right? and test the statistical value based on statistical tests. So the claim is always alternative hypothesis. This you need to remember. We try to find evidence to reject null hypothesis. In hypothesis testing, we try to find evidence to reject null hypothesis. If the null hypothesis is rejected, we accept alternative hypothesis. If we fail to reject null hypothesis, we only conclude that there is insufficient evidence to reject null hypothesis. This is how we conclude. Huh? If we fail to reject null hypothesis, means that we accept alternative null hypothesis, we can conclude that there is insufficient evidence to reject null hypothesis. Right? For example, we cannot find evidence that person is guilty. It does not mean that he is innocent. Right? So this is a simple example. Right. So now, significant level, right? Step number 2. Remember, significant level is a probability of type 1 error. So what is a probability type 1 error? So there will be two decisions, whether to accept null hypothesis or to reject null hypothesis. Right? It's a simple binomial distribution process, right? Or this is not a binomial. This is a maybe should be a Bernoulli process. So we have two conditions, whether null hypothesis is true or false. This is a true condition. So this is based on our decision. So let's say we make a decision to reject null hypothesis, but in fact, the null hypothesis is true, right? So means that we are committing type 1 error. We are making mistake, so it is called as type 1 error. So in hypothesis testing, we would like to minimize the committing type 1 error too, right? We want to minimize the error. So that's why the alpha, which is probability type 1 error, always less than 5% lah. Whether 5%, 0.05, 0.03, 0.02, 0.01, and so on lah. It means that we are trying to make our analysis as perfect as possible lah, which is 95% or and above, and sometimes 99%. Right. So to get the value of probability type 1 error, of course we need to calculate the probability value, which is a probability of rejecting null hypothesis where the null hypothesis is true. Right. So if we make a decision to reject null hypothesis and the null hypothesis is in fact false, we're making a correct decision lah. So we accept null hypothesis and the null hypothesis is true, right? So we are also making a correct decision, right? So if we accept null hypothesis and in fact the null hypothesis is false, so this is where we are making type 2 error. We are committing type 2 error. This is also known as beta, right? So beta is a type 2 error. The opposite of beta, the complement of beta, which is 1 minus beta, is equal to power of the test. Right. So this is a formula to calculate the probability of type 1 error, but we're not going to go into detail, right? How to calculate the type 1 error and type 2 error. We just need to understand what is type 1 error and type 2 error. Right? The type 1 error means that we reject null hypothesis. We are making a decision to reject null hypothesis, but the true condition is null hypothesis is true. So this is a step. There are two approaches in hypothesis testing. The first approach is by using critical value approach. Another one is p-value approach. So in this subject, we will look into both approach lah. Right. So let's say case number one. This is case first where we are using critical value. This is case one. Critical value approach. Right. So the first step, remember tadi, the first step we need to state the null hypothesis statement. So it can be either null hypothesis equal to mu naught, alternative hypothesis mu less than mu naught, or it can be null hypothesis mu equal to mu naught, alternative hypothesis mu more than mu naught. Right. This is for one tail test lah. Right. So then decide the significant level, which is alpha equal to 0.05. We decide and compute the test statistic whether z equal to x bar minus mu divided by sigma over square root of n, or z equal to x bar minus mu s over square root of n, or t x bar minus mu s over square root of n. And then we make a decision rule, calculate the critical value, make a decision rule, right? Whether to reject or to accept null hypothesis. And we make a decision and interpret the result, right? So based on critical region. So we need to calculate the critical region lah. So let's say this is example for one tail test less than. Right, so the area of rejection on the left, this is rejection area. So let's say this is Z alpha. So this, if this decision is if Z statistic less than, more than, so this is negative Z alpha, or less than lah, should be less than, right? So null hypothesis is rejected. So means that if the Z statistic lies inside the rejection area, we reject null hypothesis. So that is a decision rule, right? For p-value approach, right? We still have the same step, but this is same step as previous. The only step here is step number 4, the different, which is we need to determine the p-value equal to 2, 1 minus pz less than z stat, right? Or 1 minus probability of z less than z stat, or p z less than z stat. So, right. So decision rule for p-value, if the p-value less than alpha, we reject null hypothesis. If the p-value more than alpha, we accept null hypothesis. So this is a common decision rule for p-value. Right? Okay. Any questions so far? Boleh? Question? Don't forget to sign in your attendance. Yeah? Right. Now, sudah done? Now let's look at the first part of the chapter number 7. Hypothesis testing for one population mean. Right. So we have several type of hypothesis testing. First, one population and two population. This is chapter 7. This is chapter 8. Right. So this is we're going to look at this one next week lah. So for one population, we will look into two types of hypothesis. Testing about mean, and another one is testing about proportion. Right. So now let's focus on this one. The first one population. Right. So we're going to look into three lah. Three. This is mean, proportion, and variance. Right. So the first one mean. So we have population, variance, known, population, variance, unknown. Right. So when we have population variance known, we use Z statistic, X bar minus mu divided by sigma over square root of n. This is when the population variance is known. Right. So we will use Z statistics, X bar minus mu, sigma over square root of n. And when the population variance is unknown, so we have two conditions when n is less than 30 and more than or equal to 30. So when n is less than 30, so we will use t distribution, x bar minus mu divided by s over square root of n. And when n more than 30, z equal to x bar minus mu s over square root of n. So remember, this is the population variance is unknown. So we will use sample standard deviation. Right? So when proportion, so we will use Z distribution, P hat minus P divided by PQ over N. And for variance, we're not going to look into variance. So variance, I just bagi dekat you lah. This is chi-squared n minus 1 s squared divided by sigma square. But we're not going to look into variance. We're just going to focus on mean and proportion. This is for one population. For next week, we will look into two population. Okay, done? Right. I think this one I already explained just now. So let's say I re-explain. So first step, one tail test, null hypothesis, mu equal to mu naught. Alternative hypothesis, mu less than, this is one tail, right? Less than mu naught. Or we're going to have another one, mu equal to mu naught. Alternative hypothesis, mu more than mu naught. Test statistics. So of course, we need to state the significant level, which is 0.05. Step number 2. Step number 3, Z statistic. Z equal to y bar minus mu naught divided by sigma over square root of n. So this is Z calculated lah. So we will note this one as Z calculated. And we need to determine the critical value. So for the first half, it's going to be on the left hand side. So this is the rejection area. This is acceptance area. So this is for one tail test to the left, and this one should be to the right. This is rejection area. This is acceptance area. So this is Z alpha. This is negative Z alpha. So Z alpha or negative Z alpha known as critical value, right? So this is what we call critical value. And we make a decision based on if for this one, if Z calculated less than negative Z alpha, null hypothesis is rejected. So this one, if Z calculated more than Z alpha, null hypothesis is rejected. Okay. And conclusion, we make conclusion based on the accepted hypothesis. Conclude based on accepted hypothesis. Okay. So this is for one tail test. Okay, done. Okay, we move to the next case. Case number 2, we have two tail tests. The hypothesis statement will be null hypothesis mu equal to mu naught. Alternative hypothesis mu is not equal to mu naught. And of course, we need to state the level of significance, which is alpha. Test statistic, still same, whether Z distribution or T distribution, known and unknown. Right? Say Z is equal to Y bar minus mu naught less than divided by sigma over square root of N. And then the critical region, right, will be both sides, to the left and to the right. So we're going to have two rejection area. So this is on the left and right. So this is rejection area. This is also rejection area. And this is acceptance. So this one going to be Z alpha divided by 2, Z alpha divided by 2. This is negative 1, this is positive. And of course, 0. So we make a decision if Z calculated more than Z alpha divided by 2 or Z negative Z, sorry, Z calculated less than negative Z alpha divided by 2, null hypothesis is rejected. And we make a conclusion based on accepted hypothesis. So basically there are 5 steps only to conduct or perform hypothesis testing. Right. Easy to remember. Hypothesis statement, test statistic, determine critical value, decision, and conclusion. So this is based on critical value lah. If you are looking into p-value, so p-value, we need to calculate the p-value, right? So we no need to perform shade the area rejection or acceptance. So if p-value less than alpha, null hypothesis is rejected. So that is only one rule for p-value. If the probability value, p-value less than alpha, which is probability of type 1 error, null hypothesis is rejected. Boleh? Sudah? Done? Right. So, yes. Done? Belakang, okay? Right. So, this is recap balik for tests about mean, normally distributed, and unknown variance. Sorry, this is known variance, sorry. Make a correction. This is known variance. Right. Please make a correction. It should be known variance because Z is equal to x bar minus mu naught divided by sigma over square root of n. Right. So this is the properties that we should remember. So this is when you want to look into alternative hypothesis more than, it should be on the right hand side. Alternative hypothesis less than left hand side. And we have alternative hypothesis not equal, it should be two-tailed test. And when we have tests about the mean, variance, population variance is known, right? So we will use Z distribution, x bar minus mu naught divided by sigma over square root of n, right? So this is the rejection decision rule, right? So now let's look at example number 1. Are you okay? You want 5-minute rest? Yes or no? Okay, 5 minutes. Then we go to example number 1, right? Okay, can we continue? Right. So example number 1, right? So a sample of 40 sales received from a grocery store has mean of 137 ringgit and standard deviation of 30.20. So use this value to test whether or not the mean of sales at the grocery store are different from 150. So first of all, in this example, we have n equal to 40, x bar equal to 137, and the standard deviation, this standard deviation come from 40 sale receipt, right? So this is going to be a sample standard deviation 30.20. So the first step to make a hypothesis step testing, we state the hypothesis statement. So which is null hypothesis mu equal to 150. Alternative hypothesis mu is not equal to 150. Right. Second step is we state level of significance, which is alpha equal to. So if this, in this example, there are no instruction for level of significance. So if there are no instruction, we assume alpha equal to 0.05. So if there are no instruction in the question, we assume alpha equal to 0.05. So based on the hypothesis testing, we know that this is two-tailed test. And the population variance unknown. Right? In this case, population variance unknown. And the sample size is more than or equal to 30. Right? So when the population variance unknown, population sample size is more than or equal to 30. So we will use Z distribution, x bar minus mu divided by S over square root of n. So our test statistic, Z x bar minus mu naught divided by S over square root of n. Okay. So x bar is equal to 137 minus mu is 150 divided by S equal to 30.20 divided by square root of n. N is equal to 40. So this one should be negative 2.72. Right? Step number 3, we need to find critical region. Critical region. So based on alternative hypothesis, we know that this is two-tailed test, right? So it should be on the right and to the left. So this is negative Z alpha divided by 2, Z alpha divided by 2. And we know from here, This is rejection region. This is also rejection region. And this is acceptance region. Right. So Z alpha divided by 2 is equal to Z alpha is 0.05 divided by 2 should be 0.025. Right. 0.025. If you look at the statistical table, 0.025, let's say 1 minus 0.025 should be 1 minus 0.025 should be 0.975, right? So we need to find 0.975, should be somewhere here. Remember that? 0.975. So how do we get 0.975? 1 minus 0.05, 0.025. Right? So we will get 0.975. So we look at this value. So the value of Z alpha divided by 2 should be 1.96. Right? So this is 1.96. So this value is negative 1.96 and this value is 1.96. So if the Z statistic more than 1.96 or less than 1.96, negative 1.96, we reject null hypothesis. So the easiest way to state the decision rule, if Z calculated less than negative Z alpha divided by 2 or Z calculated more than Z alpha divided by 2, null hypothesis is rejected. Or in other words, we can say that if Z calculated lies inside rejection region, null hypothesis is rejected. Okay. So this is basically the formal way to state decision rule. This is based on for your understanding. Right. If Z calculated lies inside rejection region, null hypothesis is rejected. So decision, our decision is since Z calculated, right, which is negative, what is the value? Negative 2.72 less than negative Z alpha divided by 2, which is negative 1.96. Null hypothesis is rejected. Right. So negative 2.72 inside the rejection area, right? Inside the rejection region. So null hypothesis is rejected. So we make a conclusion. Based on accepted hypothesis. So we reject null hypothesis, we accept alternative hypothesis. So we have enough evidence to reject the null hypothesis and Include So we have enough evidence to reject null hypothesis and conclude that the mean is significantly different from 150. So this is our conclusion. Boleh? Can understand? Done? So the choice of Z statistic is based on uh, yeah, I bagi this one, the diagram, this diagram. So we are looking into mean, population variance known, population variance unknown. If the population variance known, straight away use Z x minus mu divided by sigma over square root of n. If the population variance unknown, we look at the sample size. When n is more than 30, we use Z distribution. Less than 30, use T distribution. Right. Now let's look at example number 2. So a manufacturer of sprinkler system used for fire protection in office building claim that the true average system deactivation temperature is 130 degree. So a sample of 9 system when tested yield an average activation temperature 131.08 Fahrenheit. If the distribution activation time is normal with standard deviation 1.5 Fahrenheit, so does the data contradict the firm claim at level significant 0.01? So in this example, we know that the distribution is normal with standard deviation, population standard deviation 1.5. And we take n equal to 9, x bar equal to 131.08, and mu naught equal to 130. So it claimed that the true average is 130. So the alternative hypothesis will be not equal to 130. Alpha equal to 0.01. Test statistic. Test statistic. This is known variance, right? So this standard deviation is not calculated based on the sample of 9. It's based on the distribution of activation. Right. So we are using Z equal to x bar minus mu naught divided by sigma over square root of n. So this one should be 131.08 minus 130 divided by 1.5 divided by square root of 9. So this one should be 2.16. Then step number 3, we calculate critical region. Right. So this is two-tail test, right? Two-tail test. So it should be on the left and right. So this is the area of rejection. This is also area of rejection. So this is negative Z alpha divided by 2, Z alpha divided by 2. So Z alpha divided by 2 is equal to Z 0.005. It should be 2.57558 lah. So how to detect this one? 0.05, 1 minus 0.005. So it should be 0.995. So look at the statistical table. 0.995 should be somewhere here, right? 2.5 between 2.57 and 8, right? Should be 2.57 plus 2.58 divided by 2 should be 2.575. Okay. So this rejection area, the critical value for this one is negative 2.575 and this one is 2.575. Next step, we determine the decision rule. If Z calculated less than negative Z alpha divided by 2 or Z calculated more than Z alpha divided by 2, null hypothesis is rejected. So our decision is since Z calculated, which is 2.16 less than Z alpha divided by 2, null hypothesis 2.16, right, is accepted or rejected, right? Okay, so 2.16, where is 2.16? This is 0, right? 2.16 should be somewhere here lah. Okay? So since Z calculated lies inside the acceptance region, so we accept null hypothesis. So means that, so how to conclude this one? Conclusion. We do not have sufficient have null hypothesis. So the data does not give strong okay. So we do not have enough evidence to reject null hypothesis. The data does not give strong support to the claim that the true average differ from 130. Okay. Any questions so far? So let's try example number 3. Let's try example number 3. So a random sample of 50 batteries, battery pack is selected and subject to a life test. The average life of this battery is 4.05. Assume that the battery life is normally distributed with standard deviation equal to 0.2, right? Is the evidence to support the claim that mean battery life exceed 4 hours? Use alpha 0.05. So we know that we have n equal to 50, x bar equal to 4.05, and this is from normal distribution, and standard deviation sigma equal to 0.2. Population standard deviation 0.2, and we want to claim that we want to test the claim that mean battery exceed 4 hours. So mu equal to 4. Alternative hypothesis mu more than 4. Alpha equal to 0.05. Test statistic. So since the population variance is known, so we use Z distribution, x bar minus mu divided by sigma over square root of n. So this one should be 4.05 minus 4 divided by 0.2 over square root of 50. So this one should be 1.77. Right? So by looking at the alternative hypothesis, this is one tail test. Right? One tail test. So the critical value region should be to the right. To the right because it's a seed, right? More than. So Z alpha. So Z alpha is equal to Z 0.05, which is 1.645. So by looking at the statistical table, right? 1 minus 0.05 should be 0.995, right? So look at 0.95. So it should be somewhere here. 1.64 and 1.65. It should be 1.645. So we should note that this is a rejection area and this is acceptance area. And we make a decision. So we know the decision rule, right? So I don't need to state that decision rule kalau you dah faham. So if Z alpha, so Z calculated more than Z alpha, null hypothesis is rejected. So since Z calculated is equal to 1.77 more than Z alpha, null hypothesis is rejected. So then we make a conclusion based on accepted hypothesis. So we reject null hypothesis, we accept alternative hypothesis. So there is sufficient evidence to conclude Okay, done. So this is based on critical value approach, right? So done. So I'm going to show you how to conclude based on p-value approach. So in final exam or test letter, there will be two approach lah. So either p-value approach or critical value approach. Right? No, belum. Okay, done. So the p-value in hypothesis. So the p-value is a smaller variable of significance, right? That will lead to rejection of null hypothesis. So the p-value measure the strength of evidence against null hypothesis, right? So when the p-value is small enough, we reject null hypothesis. So this is p-value. Now, how to calculate the p-value? This is for z-test, right? Z-test means standard normal distribution. So we reject null hypothesis if the p-value less than alpha. So this is the rule, right? For critical value approach, we depend on the critical value and region. If the Z calculated lies inside the rejection region, we reject null hypothesis. But for the p-value, this is a standard decision rule. If the p-value less than alpha, we reject null hypothesis. If the p-value more than alpha, we accept null hypothesis. Right. So if you have two-tail tests, for two-tail tests, to calculate the p-value, right, it should be probability of p-value should be equal to 2 multiplied with 1 minus probability of z less than z calculated. Nampak kan? So this is for two-tail tests. For one-tail test, there will be two methods. For upper tail, or if the rejection area to the right, so the p-value is equal to 1 minus probability of z. So this is should be absolute. We should take a positive value only for this one. Z less than z calculated. Okay. And for one tail test to the left, p-value is equal to probability of z less than z calculated. Okay. Boleh faham? Sorry. So this is how we calculate the p-value. Right. So now, this is for t-test, but we're going to look this one on tomorrow lah. Tomorrow lecture kita tengok t-test. For today kita we look at the z-test only. So now let's look at example number 4. We try to calculate the p-value for example number 2, 3, and 1. So example number 2, right? Example number 2, the z calculated is equal to 2.16, right? Remember? Example number 2, z calculated is 2.16. So this is two-tail test. right? Two-tail test. So for two-tail test, right, rejection area and to the right and left. So we don't need to calculate x z alpha divided by 2. So we just straight away find probability of a p-value, probability value 2 multiplied with 1 minus probability of z less than 2.16. So this one should be 2 multiplied with 1 minus less than 2.16. Right? You can look at the statistical table or we can use the calculator. You know how to use calculator? Ada aja tak? Dah pernah kan? So you can look at statistical table 2.16. It should be somewhere 0.9846, right? 0.9846. So 0.9846. Tertunjuk lah pula, sorry. Right, let's say kita we calculate using calculator menu and you choose 6 for statistic, right? And then you click on down arrow this one. Sorry, no need. Just click AC, make sure a statistic 1 minus variable, right? Again, from normal one, right? So we click on setup menu, choose statistic number 6 and click AC, right? And then you click on option and then click on down arrow, find 4 normal distribution. So we have PQR, right? So this is the region. This is PQR, right? So if you want to find the value less than, we're going to use P value function 1, 2.16. So you will get 0.9846, right? So we straight away use 1 minus 2.16 and multiply with 2. Right? Straight away use this function. So this one should be equal to 0.03. 0.0307. Okay? Boleh? So decision rule, if the p-value less than alpha, we reject null hypothesis. So in this example number 2, alpha equal to 0.01. So since p-value is 0.03 more than alpha, null hypothesis is accepted. Right. So the decision for p-value should be aligned with decision critical approach, critical value approach. Okay. Can you understand? So for example number 3, this one, right? So we have one tail test, right? More than. So more than the Z calculated for example number 3 is 1.77. So this is one tail test to the right. So to find the p-value, right, it should be 1 minus probability of Z less than 1.77. So this is also equal to probability of Z more than 1.77. Okay? Boleh? So if you are using your statistical table, you can use this formula. Right? You can straight away get the answer lah. If you use calculator, you can use this formula. Right? So remember in calculator, we have 3 region, P, Q, R. The area to the right, we will use R 1.77. So let's look at statistical table. P-value less than 1.77. So this one should be somewhere here. Oh no, see. 0.9616, right? So it should be 1 minus 0.9616 should be how much? 0.0384. Okay? Right, so this is equal to 0.0384 as well. So our alpha, for example number 3, alpha equal to 0.05. Remember? Example number 3. So since p-value is 0.03 less than alpha, null hypothesis is rejected. Okay? So if you want to use calculator, so it's the same method. You use normal. We take R. Number 3, 1.77. It should be 0.038364. It's the same value lah. Right, by using calculator and statistical table. Any question? You all understand? Very good. So how about example number 1? Can you try example number 1? Example number 1, we have two tail tests. Alpha 0.05. The test statistic is 2.72. Right? Example number 1. Z calculated is equal to negative 2.72, right? Is it? Betul ke? And we have two tail tests. So the p-value equal to 2 multiplied with 1 minus probability of Z less than 2.72. Right? We take the absolute value of negative, right? So this one should be 2 multiplied with 1 minus 2.72. 2.72 should be here. 0.9967. 0.9967. So this one should be 0.0068. So since p value 0.0068 less than alpha, our alpha is 0.01, right? Right? 0.01. Null hypothesis is rejected. Okay? So this is how we use p-value approach. So basically chapter number 7 quite heavy skill compared to other chapters. But once you understand the fundamental, then it should be very easy. We should know how to calculate the critical value, how to use the p-value approach, and how to choose statistical tests. That's all. Right. So for example number 5, 6, 7, 8, 9, 10, 11, 12, we continue tomorrow. Right. But basically it's the same thing. We just, you can try to do example numbers 5, 6 until 12. And tomorrow we will try to look 1 or 2 example. I try to compare with your calculation, whether correct or not. Right? And then we move to the next topic, which is T distribution and proportion. Okay. I think that's all. Thank you very much. Assalamualaikum. And I have your tab.